Today we're going to be creating scatter plots using bivariate statistics. Bivariate statistics means two variables. Creating scatter plots helps us to relate those two variables together. Both the horizontal and the vertical axes show numerical amounts. In order to construct a scatter plot, we're going to label both of our axes using reasonable scales. Sometimes we're going to have to use a break symbol if the data values are too large. We're going to plot the data points, and the most important thing is you want to remember you do not connect the points in a scatter plot. After we're finished plotting the points on the graph, we're going to give the scatter plot a title. So the first example we're going to look at, we're going to create a scatter plot for the following sets of data. Notice that our x value is time worked. That's our independent variable. And our y variable is wages earned. That's our dependent variable. Our x axis is now going to be labeled as time worked. And our y-axis is going to be labeled as wages earned. Now we need to determine appropriate scales for both variables. My independent variable goes from 1 to 6. Since I have enough room on my graph to go up to 6, I'm going to make each line a value of 1. And I'm going to label every other line on my graph just for neatness so I don't start scrunching everything together. Now my y-axis, I have to go from $8.50 to $51. So clearly I can't count by ones. So I need to determine a reasonable scale so that I'm going to be able to fit all those data values on my y-axis. If I count by fives, I'll be able to create the scale up to 51. So I'm going to count each line for 5. And again, I'm only going to label every other line to have a little bit of neatness on my graph. Now, when you create scatter plots, all you're doing is you're plotting the points that are in the table that's given to you. So at 1 hour worked, I'm going to plot a point at $8.50. At 3 hours worked, I'm going to plot a point at $25.50. And at 6 hours worked, I'm going to plot a point at $51. Now remember, in a scatter plot, we do not connect the points. So that's, our scatter plot is finished. The only thing we need now is the title. Since we're talking about the time we work and the wages we earn, I'm going to title my graph as wages by hour. And that's your completed scatter plot. Now, the particular scatter plot that we created, when you look at all the points that are plotted, they seem to cluster around a straight line. They make a straight line, somewhat of a straight line anyway. This graph is an example of a positive correlation. It means that the two sets of data increase together. As my independent variable is increasing, my dependent variable is also increasing. The plotted points go from the lower left to the upper right, and that's what indicates the positive or increasing variables. By contrast, in a graph showing a negative correlation, one data set increases while the other one decreases. So as my independent variable is increasing, my dependent variable is decreasing. I'd have a graph going from the upper left-hand corner of the graph to the lower right. Sometimes in a scatter plot, you're not going to see any relationship between the variables. And if there's no relationship in the variables, we're going to say that that's no correlation. So again, a positive correlation shows an upward slant on your scatter plot, similar to a positive slope for a linear function. In a negative correlation, your data points are going to tend on a downward slope, like a negative slope in a linear function. And for no correlation, the points are going to seem to have no relationship whatsoever. They're kind of scattered all over the place. Okay, on to the next page. Now what we're going to do is we're going to create a scatter plot for gasoline purchases, and this time we're going to describe the correlation. Now at this point what I want you to do is pause the video. I want you to create your scatter plot, and then when you come back I'll have my scatter plot created as well. Okay, at this point you should have your scatter plot created. Your independent variable is going to be the amount of money spent on gasoline purchases, and your dependent variable is going to be the number of gallons of gas that you purchased. So I labeled my x-axis as dollars spent and my y-axis as gasoline bought or gallons bought. My scale counts by ones on the x-axis, and on the y-axis I count by 1/2. And again, I only labeled every other line just to keep my graph a little bit neat. Notice my title is called gasoline purchases, just like the title in the table. At that point I plotted all my points. So when I had $10 spent, I plotted a point of 2.5 gallons. When I had $11 spent, I plotted a point of 2.8. $9 spent, I plotted a point at 2.3 gallons, and so on and so forth. And again, remember, when you're creating scatter plots, you don't connect the points. Now, the last thing we need to do in our scatter plot is describe the correlation. Remember, if both of our values are increasing, or if our graph is going uphill, then that's going to be a positive correlation. If our points are tending to go in a downward slope, that's going to be a negative correlation. And if the points are kind of scattered all over the graph, that's no correlation. Since my points tend to go in an upward slope, this is going to be called a positive correlation. Tomorrow what we're going to do is we're getting into more meaning behind the correlation itself, but for right now I just want you practicing positive correlations, negative correlations, and no correlations. Okay, let's take a look at number 3. This time we're going to create a scatter plot for the average maximum daily temperature in January for the northern latitudes. I also want you to tell me what kind of correlation will be involved with this scatter plot. So again, I want you to press pause, I want you to create your scatter plot, and when you come back to the video, I'll have my scatter plot created as well. Okay, this time I've created my scatter plot for the average maximum daily temperatures in January for the northern latitudes. Notice I titled my scatter plot accordingly. My x-axis, or the independent variable, is in degrees north, and my dependent variable is the temperature in Fahrenheit. I have my x-axis labeled with latitude, and I need my y-axis labeled as temperature. Now, after I have my labels, I looked at my scales. Because my latitude degrees started at 25 and went all the way up to 43, I wasn't able to count by ones or even twos. So what I did was I put a break on the x-axis, and I started counting by twos starting at 24. So each line has a value of 2, but because I put a break in there, I was able to start at 24. I did the same thing on my y-axis. I put a break so that I could start counting at 30, and on my y-axis I counted by 5s so that I could get from 30 to 80. That makes my graph nice and spread out so I don't have a lot of points clustered in one location. After I had my scales and my labels on my scatter plot, then I started plotting the points, and again remembering not to connect the points for a scatter plot. The last thing I want you to do is tell me what kind of correlation this scatter plot has. Since the points are going on a downward slope, that means that the independent variable is increasing and the temperature or dependent variable is decreasing, so I'm going to have a negative correlation. As one value increases, the other one decreases. Now for homework tonight, I want you to work on the worksheet, Scatter Plots Day 1. You're going to be creating your own scatter plots based off of some information from the internet, and I want you to tell me what kind of correlation those scatter plots have. Tomorrow we'll look deeper into what correlation means more specifically, and we'll do some more work with the scatter plots that we created today on the notes.